Hi, I am Amit Lunkad. In this video, we discuss about the structural activity relationship of Mepridine. Mepridine, which is an example of narcotic analgesic, or it is also called OPS, which is a act on central nervous system. Let's begin with the structural activity relationship of Mepridine. This mepridine, which come under this class phenylethyl piperidines derivative. The analgesic compounds in the 4-phenyl piperidine class may be viewed as a D-ring analog of morphine. Mepridine, that is pethidine, is a typical mu agonist with about 1/4 the potency of morphine on weight basis. The opiates which acts on an opiate receptor and which is one is mu receptor. So it is a mu receptor agonist. Let's begin with the SAR. For this we consider this structure, and which is nothing but the, for discussion point of view, we consider this mepridine structure. The first point is replacement of 4-phenyl group of mepridine by hydrogen, alkene, other aryl alkene and heterocyclic groups, which decreases analgesic activity. So this 4-phenyl ring which play an important role for showing analgesic action. Moving to the second point, introduction of meta-hydroxyl group on the phenyl ring increases activity. The effect is more pronounced on keto compound than on mepridine. Here is the two structures. In first structure, there is a mepridine-like structure, and here we introduce a hydroxyl group to this meta position, whereas in case of this keto-bemidone, which are having a specially keto compound, so which this keto-bemidone which are having a very good analgesic activity. Moving to the next point, the replacement of the carb ethoxy group in mepridine by acyloxy group gave better analgesic as well as spasmolytic action. Example is this alpha proline. So here is the structure of alpha proline, and which are having a very good analgesic action as well as which have a spasmolytic action. So here we introduce this acyloxy group. Next one is the replacement of phenyl group by phenylethyl derivatives is seen to be about 3 times as active as mepridine, and the aminocognate like aniridine is about 4 times more active. Here is the structure of this aniridine, so which is having a very good action as a analgesic action. So it is a aminocognate. So here look at this, here is the presence of this amino group or aminocognate. Next point is enlargement of piperidine ring to 7-membered hexahydroazepine is less active but has low incidence of side effects. So if you enlarge the size of piperidine ring, then it becomes a less active, but the side effects it get reduced. Opposite to that, if you contraction of this piperidine ring to the pyrrolidine, it gives more active compound, but at the same time it causes abuse liability. In fentanyl, the phenyl and acyl groups are separated by nitrogen, and it is 50 times stronger than morphine with minimal side effects. Its short duration of action makes it well suited for using anesthesia. So this fentanyl structure here, these two rings get separated by nitrogen, and it can be used as a general anesthetics. The 3-methyl analog with an ester group at the 4th position, like low fentanyl, which had 8,400 times more potent than mepridine as an analgesic. So here is the structure of low fentanyl. Next point, diphenoxylate, which is a structural hybrid of mepridine and methadone type, which lacks analgesic activity, but it is effective as an essential spasmolytic and is used for the treatment of diarrhea. So here is the structure of phenoxylate, and it is a hybrid of mepridine and methadone. The related parachloroanalog, that is loperamide, has been shown to bind to opiate receptor in brain, but not to penetrate the blood-brain barrier sufficiently to produce analgesia. So here is the loperamide, and here is the presence of the parachloro group. So here we discuss about the structural activity relationship. Hope all of you getting this. Thank you. Happy learning.